Hello?
Hello, how are you?
Hey, how's it going? I'm good. How are you doing?
I'm doing good as well, thank you.
Sorry for the wait. I had some problems with connecting for some reason.
It's fine, no worries.
Cool. Is it your first time on the platform?
Yeah, this would be my third time and this is my first week.
Oh, cool.
What about
Nice.
yourself?
Well, welcome.
Thank you.
I've been an interviewer for a few months now, so I've done a bunch of interviews. Are you new to the industry? Are you looking to switch jobs? Is it your first time interviewing or just brushing up your skills?
Right, so I am new to the industry. I just graduated, but I studied electrical and computer engineering.
Okay. Cool, awesome. What was the most challenging project you've worked on at school?
So it was actually a software project. We were developing a quad-core processor, but in code in Verilog, which is a what they call a hardware development language. So my team and I, we made a core, like a logic core, a cache, and a ring network. We kind of traded off roles. I was, for example, verifier on the cache, implementer on the logic core, that sort of thing. And we put it all together into this really nice quad core.
Okay. Cool. And what was it the most exciting project you've worked on?
Yeah, I think it was it's the thing I'm proudest of up to now.
Okay. What was exactly the most challenging part for you about this particular project?
Okay, so for example, when I was verifier for the cache, I had to come up with how was I going to verify the entire cache. It was a finite state machine based cache. So there were a lot of things to check. There's a lot of paths through that finite state machine that you can go through, and you have to check each one.
Right.
You have to make sure you don't miss any of them. I eventually I also wanted to kind of add in some of that into my test cases. I wanted to add in some of the locality, temporal and spatial that you might see in a real cache request. So I kind of take that idea around, how do I do this? And I eventually wrote a script in MATLAB because I didn't know Python at the time, but I did it in MATLAB, which kind of used just random chance, some probabilities that I could adjust myself to determine how if the next cache request would have the same address as the previous one, but with certain degrees of granularity, would it have the same, for example, first four bits of the same address, or the entire first 8 bits, that sort of thing. So
okay, I see.
Yeah, so I was really glad when I got all of that working.
Okay, awesome. Well, thanks for sharing. Do you see what I'm typing on the platform?
Yes, I do. I see. Hello.
Okay, awesome.
Hello as well.
Yeah, hello. Let me tell you the question verbally first, and then we'll proceed to implementing it, and I'll type it out on the platform. So you're given an integer array and a number k, and I would like you to output all pairs to sum up to this number k. So given an integer array and a number k, output all pairs that sum up to k. Let me give you a few examples. So if you're given let's say you're given this, and k is equal to 5, I would like you to output 1 and 4, as well as 3 and 2. Yeah, let me just have clarification questions about it. So yeah, that's about it.
So I want to be totally upfront. I have seen this problem before. So Is that okay with you? Like you can,
If you can just tell me what you think the solution is.
right. So you can, one way to do it, given that case, so there is one thing that, off the top of my head wrong with the solution I'm about to give. Like you can put the list in a set, and then for each number in the list, go to it, get the complement. So in this case, you'd go to 1.
Mm-hmm.
You would get the complement of 4, and then check in constant time whether 4 is in that list. And if it is, then great, you have your first pair. You would do the same thing for 3, except now you'd be looking for a 2, the complement of, right? So you see it in there, so you would output it. For the 2, you would get a duplicate, 2 and 3.
Mm-hmm.
So one thing you could do is as you get pairs, you could remove them from there. What if you had like 2 2s in there, right?
Yeah, so I don't want duplicates in the output.
In the output, but you do allow them in the...
Yes, in the array that I'm passing in, yeah.
What if you had this, so there are 2 distinct pairs, 3 2, 3 2, but they're the same pair. Would you want 2 of those outputs?
I would want the pair to only show up once.
Okay. So that should work for sets, because once you make it a set, you, at least in Python, you remove any duplicates, right?
Okay. Mm-hmm.
So after you make this list a set, it would, even if it had started off with duplicates like this, it would just turn into the list without duplicates. This list. So let's go through it. You look at this one. I think like a good strategy is to remove it immediately, because what if you had a 2? Like, what if your sum was a 2?
What if what?
If you looked at the 1, what if the sum you try to get is a 2? So k equals 2 instead of 5. If you look at the 1 and then look for a 1, you'd be finding the same 1 and returning 1 1 incorrectly, right?
Right.
So instead you could do like, okay, I have a 1, my complement is a 1, I'm gonna remove the 1 I'm looking at, and then look if there's a remaining 1. And there isn't, so you don't return 1 1. Okay. So I think that should take care of that edge case. But now let's go back to the original example. Right, so you see there's a 1, you ask yourself, is there a 4? But first you should remove the 1, as we said. So there is a 4. Right, there is a 4.
How about we actually go ahead and try implementing that solution?
Okay, that makes sense. Def, so you're satisfied with the set solution, the solution that uses a set?
Yeah. Let's try doing it. I just want to actually see that all the edge cases are taken care of. And did you want to use Python? I just changed it to Python.
Oh, thank you. Yes, I do want to use Python. Let's get rid of this. Okay. Def find all pairs that add up to, and then k, and then nums is our list. Okay, so first we're gonna make a set out of nums, so that should remove our duplicates as well. Now we're going to go for num in nums. or num set. I think you can iterate through a set just as well as you can iterate through a list. But actually, since we're modifying the set, maybe we should just iterate through the list. Okay, so now we're going to get the complement. The complement would be k minus num. To avoid that edge case that I mentioned, we should remove num from the num set. And here, remove will sometimes throw an error if num is not in the set, but here we're guaranteed for it to be in the set. Well, okay. That's incorrect. If nums originally had duplicates, we could be trying to remove a number that was that is not in the set no longer, right? Like if we had 2 ones in there. Does that make sense? So that's why I made nums back into a list. Numset back into a list without the duplicates. So now both numset and nums have the same number of digits, and they have the same digits. Okay. Now we check if complement in numset. Do you want the output as printed out or added to a list? Hello?
I'm sorry, could you repeat that? I didn't hear what you said.
Oh, do you want, so for the output, do you want it accumulated into like a list of tuples, or do you want it just printed out?
It doesn't really matter. As long as it's pretty obvious that it's a pair, it's fine with me. So whatever format you prefer.
Okay, we can just print it out for now. So there, if complement is in the num set, then num and complement add up to k. So we print them out. Otherwise, we just don't do anything, go on to the next number. And we can go ahead and test this out. We can I can run through the example or actually run through it, or run through it and by annotation, whichever way you prefer. Hello?
Let's actually make a couple of test examples and run the code with the test examples.
Okay, sounds good. So here, so let's, so for that, let's see, def, let's have a function that just tests our answer.
Okay.
Here's one version of nums that we can run through, and k equals 5, and we can go ahead and have it run on that set of numbers. Okay, nums and k. And now we can have the other, another version that would kind of test that when nums, when k equals 2 and there's a 1 in the set of nums. But there aren't 2 ones, right?
Okay.
What other, maybe like a test case where there aren't any pairs that are up to k. Let's see. So we can have 2, 5, 8, 2, 9, 0, maybe 0. And then if for big enough k, it's pretty, there shouldn't be any pairs that add up to 20. Okay. maybe another one that, what about, okay, what about one where you, like, where you have this situation? So you don't want to print out, as you said, you don't want to print out the same spread twice?
Yeah, exactly. I would only want to print out 2 and 3.
Okay. Maybe to make this, okay, I could just run this, but then we'll have to check out all the test cases visually, or I could put the expected result here, but then I would have to do this here as well. Just have a list that accumulates our results, and then this one would have to print out 1 and 4, 3 and 2, right? Only 3 and 2 once, even though it's 2 twice in there, and I think that's it for this one, right? This one would have to print out nothing, just an empty list. This one, another empty list. And this one, just the tuple 2, 3, just once. And actually, since I use print without the parentheses, we should go to Python 2. Let's see.
I'm sorry, what did you say?
So I just switched it to Python 2.
Okay, yeah, that's fine.
So let's run it. Oh, I have to tell it to run the function, test answer. Okay, so that didn't work. Let's see. Let's run through one example and see what could be going on.
Yeah.
Or let's see if we just print this out. None. It's printing none. Oh, because I'm not returning the result. That's why. I mean, at least that's definitely a bug. There might be other ones, but that's a start. So should I run it again?
Yeah.
Okay. Okay, so we did fail one test case, the first one. 1 and 4 and 2 and 3. Let's see. 1 and 4 and 2 and 3. Oh, okay. Oh, that's because it printed out the numbers in the other order.
Okay.
I don't see why though. That didn't make sense to me, but it printed out the numbers in a different order. Okay. Maybe this. What do you think? Maybe when we did the set, it kind of reordered some things. So that could be why. Should I test it some more or discuss the time complexity?
I mean, we didn't print out all the pairs. You only printed out one example. Why is it Why does it say true, 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 true?
Oh, because I'm checking against expected outputs, right?
You would do. Okay, I'm sorry.
Right here. I could have it just print out the pairs if you like. Yeah, it might not be very obvious that I'm checking here equals against the expected output. But there you go.
Okay, sweet. Cool. Yeah, if you could talk about the complexity, that would be great.
Yeah, no problem. So first of all, we are using a set. So in that set will be on the order of n, or actually, to be more precise, the number of unique numbers in nums, and that's for space. For time complexity, we are just running through a basic for loop, which just runs through each unique number in nums. And this remove operation and this membership test and this append, I think they're all constant. Especially this, like, amortized over. So sometimes, array append, like adding something to the end of an array can be O of n, but because this is probably a dynamic array, it's amortized to O of 1. So what I'm trying to say is inside this for loop, it's all constant time. It's also O of n, or more precisely, O of the number of unique.
Okay, so what if I told
numbers.
You that you can use a set?
I couldn't use a set? Okay. If I couldn't use a set, the next thing I would think of would be to sort the numbers.
Okay.
That would incur, n log n penalty time. And then I would do this. I would, so once I sort these numbers, for example, I would get 1, 2, 2, 3, 3, 5, 6, 7, 46, and there's 4 I missed. Then, okay, I would use a two-pointer approach. Let's see. Yeah, so if I point to the very first element and to the very last element, and that the sum of those is larger than the desired sum, I can decrease that by moving this to the left. So now my sum looks like 8. That's still too large, so I would decrease that pointer. My sum is looking like 7. That's still too large. Now it's looking like 6. Still too large. Now 1 and 4. 1 and 4 sum up to the desired sum, so I would output that or append it to my list. Okay, now I have a choice. I think since we're not trying to output, okay, so what if there was a 4 here, right? Since we don't want to, I guess, okay, once I get that 1 and a 4, I have used them up, so I can just increment that pointer and also decrement this one, right? But what if there was also a 1 in there? I have to account for that because I don't want to output 1, 4, 1, 4 twice. Okay, I think I have a way to account for that, and it would be just by looking back at the last thing that I appended to my list of results checking if that's equal to my proposed tuple. Does that make sense? Should I explain more clearly? Because I would I wouldn't necessarily have to encounter those in order. If there were two pairs of 1-4 in the list, I would encounter them back to back, I think. Just look, okay, I just had a 1-4. I don't need to include this one. But it wouldn't be like, I don't think you would ever have the chance where you'd have something else here and then again a 1-4.
Right.
It would be like,
okay,
it would be
cool.
contiguous.
And what would
be
the time complexity of this solution?
Right, so you can't get away from like that n log n. You have to sort it, and then after that, once you do that sorting, the time complexity is linear because you're basically either incrementing or decrementing. You're either incrementing the left pointer or decrementing the right pointer once per iteration, and they eventually have to meet up, and that will take at most n iterations.
Okay. And what would be the space complexity?
So if you do like in-place sorting, it wouldn't be any extra space complexity. It would just be constant.
What sorting algorithm would you use?
So I actually just today saw like an example of in-place sorting for quicksort, so you could do that one. I also know that you can do it with, I think, heap sort. You can also do in-place sorting, and that's also in log n.
What
maybe
kind
even.
And did that quick sort have? Was it an iterative or recursive implementation?
Yeah, it was iterative.
Okay, cool.
It was. So it wasn't like going into the stack or anything. Yeah, I actually saw it from a TEDx video.
Oh no, that's funny.
Yeah, like of all the places.
And if it was a recursive algorithm, you mentioned something about the stack.
Right. If it was recursive, then you'd use space on the call stack.
If you couldn't use if you couldn't use the 2 pointers, how would you make sure that you found the pairs?
Without the 2-pointer approach, you could do like a brute force approach where you check every unique pair. Let's see, what else? So we've already had a 2-pointer approach, a set approach. Like a hash approach would be pretty much like a set approach, but a little bit more efficient. So you're not going for that, right? No hash. Oh, okay. You can also do, once you sort them, you can do binary search. So if you here, you're looking for a 4, so you can binary search on the remainder, like from here to here, and that would itself be log n, n log n for sorting, and then again n log n for binary searching.
And log n for binary search?
Yeah, so because so at this place it'd be log n, but then you'd also do another log n here and here. Of course, the space you're searching through can get smaller and smaller, but overall it'll be around n log n.
Okay. Gotcha. Okay. Cool. Sounds good. Thank you so much for implementing the solution, even though you saw the problem before. I just wanted to make sure that we covered all the edge cases.
Okay, no problem. Yeah, I'm glad to. Should I implement one of the other solutions?
No, it's fine actually. After we finish the interview, there will be a feedback form that you should fill out if you can, and I'll do the same for you. But yeah, that's about it.
Yeah, I definitely will fill that out. So
thank you
can
so
you
much
tell
for
me?
taking the time. Yeah.
Oh, yeah, gladly. This is very helpful for me. Can I if you have some time, can I ask you a few questions?
You can leave any kind of feedback or questions on the form, actually.
Oh, okay. Thank you.
What kind of questions did you have?
Right. So, like, I just wanted to ask what you did yourself and about. So the naming here, like this name is very big but very descriptive. What are your thoughts on that?
What are my thoughts on what? Sorry.
Like so having this really large name, find all pairs that add up to, but it's very descriptive, but it's very large. Can be kind of, I don't know, like if you have an opinion on that.
I wouldn't stress out about naming too much. I would actually rather be descriptive and have one name of functions and variables than have very generic names like def function or like, I don't know, k as opposed to nums or res.
Okay.
So yeah, I think actually that's better to be descriptive than not descriptive. I think your solution is pretty clean and easy to follow. So yeah, good job.
Thank you. What about like naming like nums underscore sets? Some people, any opinions on that? Like, is there a better way to do it? That you know?
Yeah. Again, I would say that I think your naming conventions are fine as long as you're following conventions that are also appropriate for the language you're using. I personally do not use Python. I'm not really sure what the naming conventions of Python are. Like, I know some generics, but I don't know the specifics. But as long as you demonstrate good usage of conventions of the language you use and use descriptive names, I would say that's fine.
Okay, thank you. Yeah, and can I, if you have some few minutes, can I ask you what you do? Like, are you front end, back end?
I'm a back-end engineer.
Okay, and you work in what languages? In which frameworks?
I work in Ruby and Java.
Ruby and Java? Okay.
Yeah.
Can you say more about what you do, or would you rather not?
I work on a fraud team, so I deal with anything related to fraud, basically keeping the platform of the company that I work for safe. But yeah, it's just like a lot of back systems and such.
Okay, cool. Thank you very much for your time. I really appreciate it.
Yeah, of course. Yeah, thank you so much for your time as well. Yeah, if you could leave feedback for me and I would do the same for you, that would be great.
Yeah, definitely.
Yeah, have a great day. Bye.
Okay. Thank you. You too. Bye.
Yeah, thank you. Bye.